sklearn datasets. Description: explain in detail. The scikit-learn sklearn library in Python provides a collection of datasets commonly used for machine learning tasks. These datasets are readily available and can be used to experiment with various algorithms, understand their performance, and develop machine learning models. Inputs. Input 1. Explain in detail. None. The datasets are pre-built and directly loaded from the sklearn library. Input 2. Explain in detail. None. Outputs. Output 1. Explain in detail. The datasets are returned as NumPy arrays or pandas data frames, depending on the specific dataset. These arrays data frames contain the features and target values for the machine learning task. Output 2. Explain in detail. In some cases, the datasets may also include additional information, such as descriptions of the features, target variables, and other relevant details. Steps. Step 1. Explain in detail. The datasets are loaded using the appropriate function from the sklearn datasets module. For example, from sklearn datasets import load iris, from sklearn datasets import load digits, and from sklearn datasets import load breast cancer. Step 2. Explain in detail. Once loaded, the datasets can be accessed as attributes of the returned object. For example, to access the features of the iris dataset, you would use iris data. To access the target values, you would use iris target. Metrics. Metric 1. Explain in detail. The datasets are not inherently associated with metrics. Metrics are evaluated on the models trained using these datasets. Common metrics include accuracy, precision, recall, F1 score, and mean squared error, depending on the task. Metric 2. Explain in detail. The datasets may contain pre-computed metrics, such as the mean and standard deviation of features. But these are not the primary metrics used for evaluating models. Visualization plots. Visualization plot 1. Explain in detail. Visualization plots are typically created using the data from the datasets. For example, you might create scatter plots, histograms, or box plots to visualize the relationships between features and the target variable. Visualization plot 2. Explain in detail. Libraries like matplotlib and seaborn can be used to create these visualizations. Fine-tune parameters. Parameter 1. Explain in detail. The datasets themselves generally don't have tunable parameters. The parameters that need tuning are associated with the machine learning models trained on these datasets. Parameter 2. Explain in detail. For example, in a support vector machine SVM model, parameters like C regularization parameter and gamma kernel coefficient can be tuned to improve model performance. Uncertainty methods. Uncertainty method 1. Explain in detail. The sklearn datasets themselves do not include uncertainty estimates. Uncertainty methods are typically applied to machine learning models trained on these datasets. Uncertainty method 2. Explain in detail. For example, Bayesian methods can provide uncertainty estimates for model predictions. Challenges and fixes. Challenge 1. Explain in detail. Dataset imbalance. In some datasets, one class may be significantly overrepresented compared to others. This can lead to biased models that favor the majority class. Sample use case that resulted in challenge 1. A dataset where 90 of samples belong to class A and 10 belong to class B. A model trained on this dataset might perform well on class A but poorly on class B. Fixes to challenge 1. Techniques like oversampling, replicating minority class samples, undersampling, removing majority class samples, or using cost-sensitive learning algorithms can help address class imbalance. Challenge 2. Explain in detail missing values. Datasets might contain missing values in some features. Sample use case that resulted in challenge to a dataset with features like age, income, and education. Some samples might have missing values for specific features. Fixes to challenge 2: you can address missing values by either discarding the corresponding samples, imputing missing values using various techniques, e.g., mean imputation, KNN imputation, or using algorithms that are robust to missing values.